Hey everyone, welcome back to Logic Bombs. We will continue row 5 now. Let's jump in. Looking at three variables, um, two of each. Is there any way for one of these to be 0? I mean, theoretically, one could be 0, two could be 0, and one could be 5, but the most likely implication I think here is that two of them are 3. No. Two of them are 2, making it 8, and then one of them is 1, making it 10 total. Um, let's see what we can learn from the bombs themselves. Also, one zone, which is good to know. The maximum number that this Y can get is 3. Yeah, the maximum number this X can get is also 3. And the maximum number this Z can get is 2. So Z is, no matter what, locked to, at most, 2 monsters nabbed. I think the only bomb that can get this monster here is gonna be this Y here. Let me just check one thing really quick. I think, yeah, no, this has to be, this Y has to get this monster, which means Y at a minimum is 1, and this Y also has to get this monster, so that's uncontroversial there. What happens next? Are there any other monsters that only one bomb can get? No, I don't think so. I think the only ones that are limited are those two. Does it make any sense for Y to be 3 here? If we have Y is equal to 3, then we have 6. If we make these both 1, then that could work. Is that even feasible? If we have the Y's get all of these, for example, that is feasible actually. We could theoretically have Z and X equal to 1 and Y equal to 3. Is that likely? Not particularly, but it is certainly feasible. Going further down, looking at the numbers on the side and the top, I'm not seeing any other like tremendously obvious Picross conclusions where it's like, oh, we have to have like walls in certain places because of Picross rules. But we do know there has to be a wall there to stop the bombs from interacting, as well as one somewhere in here. That means there has to be a wall somewhere in here to stop these two bombs from interacting. Therefore, that's where the other two airspaces are in that particular row. I don't think we can learn anything similar. We do know for a fact Z can't tackle all of these guys. Because if he caught all of these, then he would have only 2 walls, and that would not be feasible with the Picross rule to the side here. What else do we know? Has to be a wall somewhere in here. Where exactly? Not sure. And that doesn't tell us enough to really rule out anything about this guy here. Hmm. This one is, oh, we do know something though. Because there's 3 walls in this row, even if you maximize the number of monsters this guy can get, Y can get at most one more monster in this column. Is that true here? No. Y could theoretically get all of the monsters in this column if they so choose. So what does that tell us? only one monster in this column. All the monsters in that column are viable. I guess it leaves open the possibility that the Y goes here and gets that monster. I mean, either way, if there's only one wall left in this row, then we put it here and the Y gets him, or we put it here and the X gets him. So either way, the Y or the X is taking care of this monster. Z is not taking care of that one at all. So we know there has to be a wall here to stop that from happening, revealing a ton about this solution. We now know that Z is equal to 0. Blocking off all of that, making Y get that guy. X has to get this guy. Y will get him and X will get him because of the priorly established rule about 3 in this column. We'll then solve what that shows us, which is honestly a lot. If I'm right about all my assumptions at this point, then this particular puzzle is practically solved at this point. Wall, wall. What's next? Solved entirely. What's next? Practically solved, I say, as I immediately run into a stumbling block. Oh, wall, wall. Does that show us anything meaningful? There has to be a wall in here to stop this bomb from interacting with that monster. Therefore, we've solved this column and that column. That then gets us a step closer to solving the rest of it. Exactly how? TBD. That's empty as well. That solves that column. Solving that column. Solving that. What's next? What is next? I guess we can try to figure out what the slime here is telling us. Has to be a wall somewhere in here. Has to be a wall somewhere in here. Has to be a wall somewhere in here, meaning that these are all taken. Because there's 3 between these 6 tiles, there's 3 guys, meaning that these columns are basically solved. There's empty space there, there's a wall there. There's a wall there. And then should this be obvious? I feel like it should be obvious. Oh, the wall has to go here because otherwise this guy gets blocked off, meaning these 2 are walls. Huge. Once you figured out that clever trick at the beginning with the 1 row, it kind of all just fell into place. Let's move on to the next puzzle. Oh, interesting. It's got the fun aesthetic too about it. This weird liminal space full of, not liminal space, that's the wrong word for it. This abstract expression of the various fellows floating in air. Well, we know there has to be a wall somewhere in here, making all of this open. Wall somewhere in there, definitely a wall there. Then a wall somewhere around here. There has to be a wall somewhere in there. Not enough to solve this row. Has to be a wall there and somewhere in there, making that open. Has to be a wall there. Solving that row entirely. Also has to be a wall there, meaning that all this is open, therefore there has to be a wall there to stop these 2 bombs from interacting, which solves that row, which then means there has to be a wall here to stop this bomb from getting that monster. What's next? I'm sure that unlocked something around here. Oh, these are completely solved. Oh, this has to be a wall here to stop this monster from getting hit by this bomb, vice versa, I mean. Then there has to be a wall somewhere in here, making this open. Yep. What's next? Oh, it has to be a wall here to stop this bomb from interacting with this monster. Then we have, oh, a wall here just to solve the row. A wall there, which solves that column. A wall there, which solves that column. Has to be a wall here. Therefore, this is open, and there's a wall there. Solving that column, which then tells us there's a wall there. Solving that column. What else is solved? I'm sure something else is solved. Hmm. Well, it can't be this, because that blocks off this monster here. Oh, in effect, this has to be open. Blocking off that, and this has to be open to preserve a pathway here between these two monsters. Therefore, that's the solution. No, that's blocked off down there. Oh, I didn't even notice the guys below. They get blocked off too. Ooh, that's clever. This, perhaps? No, it's the exact same thing I just did. What am I doing? What am I doing? Oh, it's not symmetrical. That's what it is. Okay, let me stop futzing around here and actually try to figure this out. We can't have this and this and this and this. But could we have that, for example? No, because that still gets blocked off. What are the possible combinations? The only ones are this and this, and this and this, and that one's just not going to fly. So it has to be that and that, no? But then how do we get in there? Is there an extra wall anywhere? I'm looking. I don't see any extra walls. Wait, no. That's okay. Because the difference was next to the top bomb, there was a wall blocking off. Is this still solved if I go in there? Yeah, up here, there's no wall. Here, there is a wall, which is the difference maker there. Huge. Let me just look at this for a second. This is all empty. So is that. So is that. So is that. This looks like a pure mathematical one, where we have to just assign each variable a value and hope for the best. In this case, what's even possible here? And the values can't repeat. Never forget, no repeating values. The vibe I'm getting is the maximum that x can be is 1. That is the absolute most it can be, and x has to be 1, because there's no other way to get these monsters here. Therefore, x is 1, there's a wall there blocking off all that, putting a wall there, opening up all of that. Then, A is equal to either 3 or 1, and the same is, or 0, I mean, and the same is true for B, equal A or 0. If A is 0, then B has to be 3. But B cannot be 3 here because there are only 2 monsters available for this B to hit. Therefore, A is 3, and B is 0, making Y 2. Is that solved? That's solved. That was very straightforward. I'm a little surprised, to be honest. Let's move on to the next level. Okay, all the monsters are accounted for. There's a wall here for sure. Oh, there's 5 different slime zones. Well, this slime can't touch this bomb because then he would be touching. There's only one bomb available for each zone. Therefore, this slime I can't touch this bomb here. These guys can't touch. Can't touch there. Could touch there. No problem with that touching, except that's all walled off. Oh, they actually tell us exactly what's already walled off. I didn't even notice that. Oops. Meaning this guy has to touch either this one or this one. And he feasibly can because he can put the walls there or there. This is all empty. Well, we have to have walls there because we can't have this group touching that group. What else do we know? We know this is walled off too because either that is open to allow that guy through, or this one's open. You can't have, I guess you could have both open. No, you can't have both open because there's only, yeah, no, it has to be like this. That's like nearly self-evident, I think. Self-evident. Block off that. Block off this. What's next? We also need to block off this because those two groups can't touch. Does that solve anything for us? We're one away from solving this group here. Which slime is going to touch this group? Could it be this one? It cannot be that one. There's not enough leftover room to make that possible. Therefore, this slime touches, presumably with a direct path. I can't really imagine another way for them to touch. That has to be a wall. This also has to be a wall. Then, what's next? Are there any other just like solved rows that I'm missing right now? This guy cannot just... Oh no, he can if we put the last wall here. Okay, let's do some theory testing here. If we put the wall here, then this is all open. In order to get around that, he has to touch that. Yeah, no. I don't see a way to put the wall anywhere without forcing this guy to touch this group here. Therefore, the wall goes there instead. Which does not solve that row yet. Not solved yet. But there is a wall there for sure. What is next? I what is next? Yeah, that's not quite solved if I put this. There's no reason to put that there, though, so we can just leave that be for now. Oh, this is a solved row. Or column, I mean. Hmm. If I wanted to have this be open, I'd have to put... Let's think about this. Let's think about this. If I had to put this guy here, then that would block off this, this, this. But more importantly, it would force me to put 3 in here. Oh, what am I doing? Is it even feasible? Okay, we need to block this guy off from the world. Is it feasible to have that be how we block it off? I guess that's feasible. Impractical, surely, but feasible, yes. We do this, all of this. This is starting to get a little bit tougher. I did not foresee this one becoming a difficult to pick lock. Let's say there's a wall here. That's open. There has to be a wall there. That mostly solves that. That's not really a problem. I... There's only one in here. We put this here. All of this is open. What does that imply about the rest of it? Wall there, wall somewhere in there. And then if I have walls here, is it okay for all this to be open? This is already solved. That has to be open, which makes that there. Yeah, okay. Open all this. Therefore has to go there. Sorry, repeat myself. Let's just... I'm repeating myself. Let's just math it out. 1, 2... You only need that one, I guess, but you also get that one for free. Then this is open. That has to be open. To have this work, that has to go there as well. So then, boom, boom. That has to be a wall. That's walled off naturally. Has to be open. Thus, one of these is a wall. Doesn't really matter which. Has to be open, has to be open, has to be open. Oh, okay. I didn't mean to solve it. I was just kind of following the logic innately through if we do the 50-50 there. Okay. I kind of stumbled into the answer there. Hopefully the next one is a little bit less arcane, I suppose. Now that's weird. Giving us all of this off the bat, that is unusual. Wall there for sure. We have to block off these 2 zones without blocking off this guy's access to this monster. Well, I mean, this is the kind of level where I usually just start imagining what the solution could be, and it gets us kind of close. There have to be 2 walls here and 2 walls here. to me, that gives that, or because it can't be these. Because if we have this and there's space there, and then this guy has to touch this bottom group somehow, therefore it has to be a wall there. It has to be a wall there. What does that tell us next? Well, if we have a wall here, this touches. No good. Has to be air there. If we have a wall here, that touches. No good. Has to be air there. Same thing happens here. No, it doesn't necessarily happen actually. But we can't have it there, therefore that is air. It's not really important whether it's here or here yet. Nothing to solve there. It'll touch, not gonna work. It'll touch, not gonna work. It'll touch, not gonna work. The same exact thing here. Therefore, boom, boom. Those are open. Those have to be open to allow for the crossover. Those are all walls. Then there are walls here. That was not so bad. Next up. Let's think about it. 2, 2, 2, 2. The obvious implication here is you have all of them equal to if it's wait, I was doing the math wrong, never mind. But for me what this implies, because you can't have these variables repeat the same value, it's 0, 1, 2, 3, because you get 2. If this is 0, 0, 1, you get 2 monsters. 2, you get 4 monsters. Then you get 6 monsters. All that together is 12. So I think it's 0. I think it has to be 0, 1, 2, 3. Which of these could be 3? It can't be Y. It could be A or B. Can it be X? It cannot be X. X and Y have to be 0, 1, or 2. A or B can be 3 or... Well, they can't be 0. Because if A is 0, then B is 4. And I don't think that's possible to work through with our solution. Therefore, A and B are numbers, and X and Y... A and B are numbers greater than at least 1. X and Y are less than 3. 2 zones. It's always these zones, man. What that does mean is that we can't have the one wall be here, for example, because then B ends up being an impossible number in this situation. Therefore, the wall is either here or here, making these both open. Same exact logic applies here. Open, open, there's a wall somewhere in here. If we put the walls with the A's, same implications if we put the wall here. Wait, no, if we put the wall there, wall, wall, or wall, wall, wall. Yeah, nothing quite breaks. It's all still feasible. We also know that because one of these has to be 0, given that both of these have to be some number greater than 0, the wall has to go either here or here, making all of this open, which then solves that for us. A is 3. Let's put a wall there to cap it off. Which is 0, X or Y? We're not sure. Doesn't quite matter yet, I don't think. Okay, looking at the slime rules, we have to block off this section from the rest of it, because the rest of it is all like one big zone. This is an isolated standalone zone that we have to effectively block off. How? Well, first off, we put those there, which solves that row and that column for us. What's next? I don't know. But we will know soon. This is a solved row. That's a solved column. That solves that row and that column for us, which then makes us progress, but doesn't quite get us all the way there yet. Does that solve any other rows or columns for us? No, I don't think so. There has to be a wall here to stop these bombs from hitting each other. Nice. Is there something similarly true anywhere else? I don't think so. Oh, we can't have a wall be here because then the bomb is entirely on its own. That's no good. That'd be its own zone. Therefore, the Ys are the ones who attack the monsters, and the X's are zeros. Just solving what is solved for us. Awful phrasing aside. We have to block off there to stop the two zones from connecting. Same goes there. So that solves how we block off the zones. What's next? And there's one more wall somewhere in there. Exactly where, I do not know, but it doesn't really matter yet because that row and column are solved, thus solving all of that for us. Huge. Exciting. Last level of row 5. Let's jump in. Oh, there's a lot going on here. Okay. Surprisingly, no variables. You'd think they used the last level to really stretch that concept. We're basically looking at, for each of these sets of bombs, this or this. That's like what we're doing here. If we do this and this, then those connect like that. And those like that, and those like that. But we can't do that for both of these. I think they're going to be non-symmetrical. This seems like a vulnerability. Let's examine this in more detail. We have to have... Oh, how do you solve that? The way I read it, you're only allowed to have one bomb, which means, like, that's possible. Meaning, this and this and that. But then you wouldn't be able to have a wall either here or here. If we have those open, then it has to be like that. There could be, and there has to be a bomb. Ooh, there has to be a bomb somewhere in the middle here to stop this bomb and that bomb from interacting. Therefore, these have to be open. Just unequivocally. That is how we solve those. Putting a wall there and there, and a wall there and there to stop those bombs from interacting. There has to be also a wall there and a wall there to stop those from interacting. Meaning, yeah, this guy has to get that one, this guy has to get that one. Same goes here. Has to interact with those particular ones. Next up... What is next? Okay, let's start logicking our way through the rest of it. 1, 2, 3... Okay, it's feasible to block this off and still have all the walls we want here. But is there any reason that there has to... Oh, this is solved. That entire column. Meaning that's also solved. which then gets us a large part of the way towards solving that. Yeah, okay. 1, 2, 3, 4, 5. That's also solved. Also solved. Tremendous. Solved. Open. The zone is going to flood out this way, so we have to make sure that this isn't blocked off in any way over here. Sorry, what's next? Oh, that's solved as well right there. I'm looking at this, and the next step is not immediately coming to me. Yes, it is. I lied. There has to be a wall somewhere in there to block off these bombs. Therefore, we have to have these be aligned like that. Wall there. That's open. This is open as a result. Any other solved rows or columns as a result of that. No, I don't think so. Oh, that's solved. I lied. What does that do for us? That's open too. Oops. Are there any other just unequivocally solved rows? How about solutions involving bombs? No, not quite yet. Nothing solvable, at least. Nothing that is certain to be true. Oh, what am I doing? We have to have one of these guys be shut off by the nature of how this particular guy is looking. So he has to be able to go all the way around. Therefore, this has to be open. That's the whole thought. That has to be open. What else has to be true to make sure that it can all connect? That's already one of these has to be open, but that feels true already. um. I don't see any other bottleneck for closing off the entire solution except for here. But I don't. The only thing that tells us is that we can't have both this here and this here. We could have that open and that there without issue, or vice versa. But I'm not sure that's enough to build a solution around yet. Fewer than three bomb or walls misplaced, which is good. I am happy with that. Let me do some logic on the outside here. There has to be one in here. It has to be one in there somewhere. It has to be one in here. It has to be like one in here. Up to two in here, actually. Does that mean this is like somehow already solved and I just didn't even know it yet? Like, what does that tell us? We could have both there, I think, without issue. If we have both of these here, then we like block off like this, that. Is there a problem? I don't think so. Oh, what am I doing? This bomb has to hit this guy if we don't have a wall here. Therefore, there will be a wall there. That's open. That's closed. That's open. Both of those are closed, forcing this to be open and that to be closed. All of this is open. Those are solved like that. Huge. You miss one little thing and suddenly the whole puzzle unravels before you. Well, that was pretty straightforward. A relatively intuitive batch of levels. Glad to see it. With that, thanks for watching. I'll see you next time.